A planetary nebula has nothing to do with planets. The shells of gas thrown off by dying stars are the most photographed objects in astronomy. Rings, hourglasses, butterflies, glowing shells with a small white point in the middle. They are called planetary nebulae, and there are no planets involved at any stage. The name is from William Herschel in the 1780s. Through the telescopes of the time, a small, round, greenish disk looked like the disk of Uranus, which he had found himself a few years earlier. The name stuck, long after everybody knew it was wrong. Astronomy is full of these. What they actually are is the outside of a star, lit from within. The exposed core left behind is extremely hot, tens of thousands of degrees, and it floods the departing gas with ultraviolet light. The gas glows in specific colors depending on what is in it. Oxygen gives the green, hydrogen gives the red. The important part is how short they last. The gas keeps expanding and thins out, and the whole display fades within about 10,000 to 20,000 years. In the life of a star, that is an instant. It is the reason there are only a few thousand of them known in the entire galaxy, while there are hundreds of billions of stars. At any given moment, almost nobody is doing it. Every one of those photographs is a star, in the middle of a step it will finish, before recorded history could have been written twice. What is left is an ember that has not finished cooling anywhere. The core that is left behind is not a star. It makes no energy at all. Nothing is fusing inside it. It is simply an object that is extremely hot and has nothing to do but cool down. It is also astonishingly small. Take something with the mass of the sun and squeeze it to roughly the size of Earth. A piece, the size of a sugar cube from inside one, weighs about a ton. What holds it up is not heat, which is why it can stop making heat and still not collapse. It is a rule about how closely electrons can be packed together, and that rule does not care about temperature at all. It also gives the object a hard limit. Above about 1 4/10 of the sun's mass, the rule fails, and the thing collapses further, which is one of the cleanest numbers in the whole subject. Then it cools, and it cools very slowly, because it is small and has almost no surface to radiate from. Calculations put the time to go completely dark at something on the order of 1,000 trillion years, so there is no such thing, yet, as a burnt-out star. Not one. The universe has not been running long enough for the first white dwarf to finish. The coldest ones found so far are still around 3,000 degrees, and their ages, read from that temperature, come out near the age of the galaxy itself. They are used as a clock for exactly this reason. Everything that has ever died out there is still warm. Some of the gold in the world was made by two dead stars colliding. Ordinary fusion in stars cannot make gold. Past iron sticking nuclei together takes energy rather than giving it. So the heavy elements have to be built somewhere with an enormous supply of loose neutrons and no time to waste. For decades, the sites for that were argued about. On the 17th of August 2017, one of them was watched directly. Detectors on 2 continents felt a gravitational wave, a ripple in space, that lasted about 100 seconds and had the signature of 2 very dense objects spiraling together. 2 seconds later, a satellite recorded a short burst of gamma rays from the same direction. Within 11 hours, telescopes found a new point of light in a galaxy 130 million light-years away. That point of light then behaved exactly as predicted for freshly made heavy elements. It faded from blue to red over days as a cloud of newly built atoms expanded and cooled. Estimates of the amount of gold produced in that single event run to several times the mass of Earth. The honest part is what remains open. That mergers make these elements is now observed. What fraction of all the gold and platinum in the universe comes from mergers, and what fraction from rare kinds of exploding star, is still an active argument, and papers disagree. The metal in a wedding ring was made somewhere violent. Which kind of violent is not fully settled.